Hello all. Today we will be discussing about credit card fraud detection project using Pycaret. That is, with the help of credit card and transaction details, we'll find out which one is a fraud transaction. This whole problem was uploaded by a company as a competition in Kaggle few years back. I have taken the dataset and the other details from there. You can also check it out. Now moving on, what is the motivation behind this project? What is the need for this project? It is important that the credit card companies are able to recognize fraudulent credit card transactions so that the customers are not charged for items that they did not purchase. It is a very important concept and a very important problem. What happens is there are various fraud transactions you might have come across which either you have not done or have done by a third party. It becomes very important to identify these transactions and find a way to stop them. Now, but what is a credit card fraud transaction? A fraudulent card transaction is an unauthorized transaction that is carried out with your credit card. The thief either physically steals your credit card or steals your card information. We are pushing on credit card skimming and uses it to make payments or withdraw cash. You might have heard about this in your family members or various other things in your neighborhood that a person has done a fraud transaction. So this is a very big problem and this needs to be identified, and this is a very common problem across our society. Various hackers or different scammers are there which do credit card fraud transactions. But how exactly will we do that? There is a method named anomaly detection, or also known as outlier analysis. Now, what is anomaly? Anomaly means something that deviates from normal, which basically is the meaning of an outlier. These algorithms do the same. Anomaly detection is a step in data mining that identifies data points, events, or observations that deviate from a dataset's normal behavior, which means in case of a problem, the fraud transactions will definitely have some behavior which will be deviated from the normal. So our work will be to identify these transactions. There are different methods. There are some methods like Z-score, interquartile range. These are the methods to find out the outliers. But these can be very tedious when we are doing them in a large data set and will take a lot of time and will not be that accurate. So in order to have the best accuracy and precision, there are certain libraries in the machine learning like isolation forest, one class SVM, local outlier factor. I'll be explaining you these libraries when we proceed further to these sections. But our main aim is to solve this problem with the help of auto machine learning techniques. How do we do that? How can we automate all these things with one single line of code? Let's talk about auto machine learning, automated machine learning to be precise. That is our main concern, of course. AutoML helps you to perform all the model building part which we will be doing in the previous section and replace it efficiently with few lines of code. The auto machine learning library we will be using in this project is Pycaret. Pycaret is an open source low code machine learning library in Python that allows you to go from preparing to data to deploying your model within minutes in your choice of your notebook environment. I'll be explaining you the concepts, the various methods in the upcoming sections. Now, there are certain advantages. Why should we use Pycaret? One of the advantages is that it increases productivity, it's easy to use, and it's business ready. You'll find out how it's easy to use and how it is business ready. It's business ready because it provides us the opportunity to deploy model in any instance. Take it Azure, take it AWS. It is very easy to deploy these models and it is very user friendly and it's very easy to use, and it has a very good model explaining characteristics. So what will be the timeline of the project? First, we'll do the different data analysis on our project. We'll understand how the data is distributed, how it is correlated. Then we'll build the model using the machine learning techniques which I showed you earlier. Then we'll finally come to the auto machine learning part and we'll see how we can do all of these things with the help of automated machine learning. In the end of this video, you'll be able to do all these and implement on your own. So let's begin. Hello all. So let's proceed to our project credit card fraud detection using Pycaret. As you can see, these are the different literatures which I have taken from the Kaggle notebook. It tells us the context which I have shown you earlier, that why there was a need for this project. Now in the content they have told us that this data it only contains numerical input variables which are result of PCA transformation. What is PCA? PCA stands for Principal Component Analysis. This is basically a process of dimensionality reduction process which data scientists usually use for a better output for their model. Now, this is a process of computing the principal components and using them to perform a change of basis on the data. They have done this because of the different confidentiality issues. Of course, they cannot provide their data, the user data directly to us. Now, in this data, there are different features V1 to V28, which are the different components, of course. Then there are different time, amount, and class variable. Time is the time of transaction, amount is the different amount of that transaction, and class is basically a dependent variable. If it's 1, it means that it is a fraud case. If it's 0, then it is a normal case. Now, let's proceed with the task we'll be performing. Data analysis, feature engineering, model building using ML techniques, model building and prediction using Pycaret, that is the automated machine learning. Now the libraries. These are the libraries: Pandas, NumPy, Matplotlib, Seaborn, sklearn, SkyPy, sklearn.metrics. I have implemented this. These will be used in the data analysis. Metrics part is used for the evaluation of a project of the models, to be precise. Now these are the different libraries which will be used for outlier detection. I have explained you, I have told you in the introduction part, the isolation forest is the technique which we will be using in the one class SVM. I'll be explaining these in the further sections. Now let's read our data set. Now what happens is, in this data set, this is a Google Drive environment. So there's a certain procedure. What you have to do, you have to write from google.colab import drive. Then you have to write this command. When you'll execute this, I have already mounted my drive. So it is giving that drive already mounted. When you'll execute this, it will give you a certain link. You have to click there and select your account. It will give you a path. You have to paste it here. It will give you a box. Then your drive will be mounted. When your drive will be mounted, it will be shown here. As you can see, it is here. Now what you have to do is select your path. You have to copy this path. Then you will paste it here like this. Then you'll execute it. If you want any of the file, you just have to upload it in your Google Drive, then mount your drive, then select your path and paste it and write pd.read csv. Then it will automatically read your data. This is the data set v1, v2 to v28, the time, and the amount and the class. The amount and the class is the basically dependent variable. So this is how you read your data, and this is a basic summary of our data. We'll proceed in the different next sections with the data analysis part. Hello all. So now let's proceed to our data analysis part. Now first thing I'll be doing is I'll be seeing what is my shape of the data set. As you can see, these are the number of rows and these are the number of columns. The number of rows and columns is very large. This means that this is a very large data set. After this, we'll see if there are any null values. There are no null values in our dataset as it is a result of PCA analysis, so there will be no null values, of course. Now let's check the distribution of normal and fraud cases in our dataset. For this, I will be using a command pd.valueCounts. As you can see, what this will do, this will give me the count of the different variables in the different categories present. I'll be using the class variable, which means the 0 and the 1. I'll be plotting a bar plot. I'll be using the different names. Now, as you can see, this gave me a beautiful chart which shows me the normal and fraud cases. Now here the xtext command is used to map my values, because earlier if I undo this, it will give me a graph of something like this. As you can see, this is 0 and this is 1. So I don't have any understanding. For a new user, I want to make it as much as understandable as I can. So I'll use the xtext command. I'll give the labels part in which I have defined the normal and fraud. This will basically map my 0 for normal and 1 for fraud. When I'll execute this, it will give me a chart which says the normal is for this and fraud. After seeing the graph, we see that above 2,50,000 transactions are the normal transactions and very less are the fraud transactions. Now let's see in number. What is the shape? I have defined the for class 1 it is the fraud people, and if the class is 0 it is the normal people. Now after seeing the shape, the fraud people shape is 492 and the normal people shape is very large, above 2,84,000. So as we can see from this information, our data set is pretty imbalanced. Imbalanced data set can sometimes cause a problem while model building, as the model gets confused or gets shifted toward the most abundant part. Now we'll be using the automated machine learning and see how our models will perform in the imbalanced data set. Now the another thing we can do is we can describe the amount, what amount are used in the fraud transaction and in the normal transaction. In the fraud transactions, you can see this gives me the count that there are 492 transactions and the mean is 122 and the maximum amount is 2125. This is quite low, as this can be an indication of a fraud transaction. As you can see in the normal transaction, the maximum amount is above 25,000. So there is a huge difference between these two, which shows us the difference or which helps us in categorizing the fraud and the normal transaction. Now these are the numerical variables, right? So let's visualize it. Let's visualize and see how it will look. Okay, sorry. Okay, it will be, as you can see, this is our graph. What I did is I plotted a histogram. First I used the data from the fraud people amount, and then I used the data from the normal people amount. And I used the scale as the log scale. So the data distributed in the y scale is logarithmic. It will help me in visualization. Now I used the command sherix. If I do this as false, what it will do is it gets overlapped. So the sherix command is used to make sure that our graph do not overlap. See, now it's not overlapping. So the x is my amount and this is the number of transactions. It is on the 10 to the power part, as it's a quite high number, and these are the 0 to 200. These are quite low. Now let's plot a correlation map, basically a heat map. Correlation GF dot correlation is something that it will give me a chart which will show me the correlation of different features. Then I'll convert it into a heat map and visualize it. Now as you can see, we have a very beautiful map which shows us the different color ranges, that how these variables are correlated. Now as it's a pretty imbalanced data set, it is very low. It is quite low, minimum bearing to zero, bearing to point 0.2. As you can see, they are quite less correlated, and you can use this heat map in a different way. And I use this anet command. If I'll do this false, if I'll just change it to false, what I'll do, okay, sorry, as you can see the text is gone. So the anet command makes sure that it overlaps the text, or it adds the text which is present in our data set to our heat map. It will take some time as it's a large data set. Now let's see. This is a perfect heat map. You can explore the heat map more and try new different things. Now let's convert our features into a dependent and independent variables. As the features are a result of PCA transformation, there is not much to do in the data analysis part. So let's proceed to model building part and the splitting a data. Now what I did here, I used a list called columns, and I took all the columns from a data set and converted into a list. Now what I am doing, I am making my independent variables. What I am doing is I'll use variable for variable in columns if we're not in class. So what this will do is this will take all the variables from time to amount excluding the class. These will be my independent variables, and I'll be making a variable target which stores the value class, and I'll be storing it in a data frame. Then see the shape. X shape is the all the different features with 30 columns excluding my output variable, that is the class, and this is my class variable. If I'll see it in a data frame, it will be like this. This is my whole independent features and this is my dependent features. So this was the part of our data analysis part, then the next section will be doing the model building. Hello all. So let us start our model building procedure. For this procedure, we'll first split our data into different sizes. That is, they will take the test size at 30% and the train size at the 70%. They'll be split it into X train, X test, Y train, Y test. Why did we do this? So this will help us in validating our data, checking the accuracy. Now, as we see that I told you that I'll be using isolation forest and one class SVM as our models for the anomaly detection. So let's talk about isolation forest first. Let us discuss on how isolation forest algorithm works. This algorithm is completely unique of random forest algorithm. So if you know random forest, you will not have much difficulty in understanding how this basically works. Now let's see how isolation algorithm works. So there's a brief introduction that one of the newest techniques to detect anomalies is called isolation forest, and this method is highly useful and is fundamentally different from all existing methods. How isolation forest works: the isolation forest algorithm isolates observation by randomly selecting a feature, then randomly selecting a split value between maximum and minimum values of the selected feature. The logic argument goes, isolating anomaly observation is easier because only a few conditions are needed to separate those cases from normal observations. On the other hand, isolation normal observations require more conditions. So what this means is that, as we see, what is random forest use decision trees. So what it does is the random forest create many different decision trees, then it helps split. Now what happens in isolation forest, as we know, everybody is familiar with working of decision trees, right? So it creates number of trees, and now what happens is this split is assigned a value up to the split. The isolation forest, what it does, it assigns a value to every split. Let's say score, let's consider a variable score, so that the value of that split uh, is in that variable score. This score increases with depth. As soon as the depth increases, the score value will increase. Now, if an outlier comes, in case of an outlier, the split will occur faster as there are less number of points. There will be less parameters to split. So the split will become faster and the score value will be less. Than the normal value, as it has less points, hence less value. Based on this score, it will select what is the outlier, because these outliers are very rare. As it's written, the logic argument goes, isolating anomaly observation easier because only a few conditions are needed to separate those cases from the normal observations. The way the algorithm constructs the separation is first by creating isolation trees or random decision trees as discussed. Then the score is calculated as the path length to isolate the observation, which means that if the score is less, the algorithm will automatically know that this is an outlier and it will separate it. And when then in case of the normal points, the score will be more as the depth will be more because there will be many number of points. So this is how the isolation forest work. It completely runs on decision trees, same as the random forest algorithm. The only difference is that it uses it assigns some value, let's say score, for every split. This is how outlier is detected. Now, so let's implement it. What I have done is I have imported the earlier when we imported the different libraries, I have imported it from there. Then now I'll fitting it, I'm assigning it. What I did, these parameters I have literally taken from the net. I've seen that which parameters are the best. You can also have a documentation of isolation forest. It will show you, okay, what are the best parameters. See, these are the different parameters. It will tell you what things we should use, what things when we have to use. You can have a look and proceed. Now I'll fit my data. I'll fit my data to X train and Y train data. What this will do, this will fit my the X train, that is the independent variables, and the Y train the dependent variables. As we see, my model is fitted with these number of parameters. Now let's predict the results. It will take it will take some time as it's a large data set. So now as we see, more predictions are now. This one problem that the predictions are in the form of -1 and 1, which means that -1 will belongs to our one category, that is it is a outlier. It assigns to -1 that it is a outlier. So what we'll do, we'll map these values to 0 1 as a test output is in the 0 1 format. What we'll do is y predict equals to 1 assigns 0, if it's -1 assigns 1. Now of the results are in the form of 0 and 1. Now we'll see how good a model is performed. We'll see a accuracy score. As we see, it's 99.7%. As we see, it's quite good. It's performed very well in our model. This is the classification report. We can also import a confusion matrix. As you see, this is the confusion matrix, and this is the number of true positives and true negatives, and how it is performed. So as we see, a model is performed very well. There is another one. There also we can print how many errors a model have made. How we can do this? We'll assign a variable n errors, which will do what I have done is it will tell me that the how many times my prediction is not equal to my test data. It will sum all of it and give me. See, isolation for a 188 errors. That means that 188 times, as we see, this is the from the confusion matrix only we are having. The 188 times this model has not performed well. It is given an error. Now, beside this, there is one more algorithm which is local outlier factor. I have not discussed it here, but it works on the same way. The only difference is it works on the density. If the density of a cluster is less, it will consider it. If the density of the points is less, it will consider them into an outlier. This is how it will work. You can you Google it, research about it, and implement it. It will be implemented the same as the previous one. Now another one I took it is SVM. The problem with SVM is it will surely underperform at it works on a decision boundary line. It makes a decision boundary line which is a linear line, which will not work well in the case of outliers. Also, I'll not run this first. I have taken these parameters from the net, which one is the max. Sorry, I've taken these parameters from the net which are the best. I have fitted. I'll not fit this because the problem with SVM open one class SVM is it will take a lot of time. As the data set is huge, it will take a very long time. It will take around 15 to 20 minutes to get fit. So in order to, if you want to implement it, you can split your data set into a smaller size. Let's take it 20 to 30%, then you can fit it. Although it will not perform well because, as I said earlier, it works on a decision boundary line. So we'll go with this model, our isolation forest model, or you can implement local outlier factor also. So this was our primitive machine learning techniques, and how did we get the accuracy score. We saw how we will do all these things. Now in the next section, we'll see how we can solve this problem with the automated machine learning techniques. We'll be using Pycaret library, which we will discuss in the next section. Install that library in your environment. I have already installed it. It will take 2 to 3 minutes for installation. As you can see, it has already installed. Now what we have to do is we have to read the data from the previous time, like same as copying the path from our drive and pasting it here. Now we have this data. As we can see, this is the same data as above, different feature with time, amount, and class variable. Class is our dependent variable. Now what we will do, we are using Pycaret.classification module. In this problem, we can also, there are different problems in this. We are using Pycaret.classification import star. What this command will do, it will import all the different libraries which the Pycaret is having in classification method. As you can see, there are different libraries. When I'll go to model training, and this is the compare model, create model, tune model, these are the tutorials. These are classification, regression, clustering, anomaly detection. One thing you can do is you can also select the anomaly detection part. I have used classification model, but you can also select the anomaly detection part. Yeah, you can do as your home assignment. Now what we have to do is we have to set up our data, set up our model. What we'll do, we'll type the command model is equals to setup data is equals to df target class. Target class means it will be taking my dependent variable and giving me the different models. I have taken this command from this function. We'll go to model training and we'll go to compare models. As you can see, there is a command importing modules and initializing setup. We'll import from Pycaret.classification import star. We'll set up the data and we'll provide a target variable as we have done here. There will be a pop-up window. We have to type y, that means yes.
then it is basically for confirmation, as it is asking us that the values which it has chosen, that is the numeric values, they were right or wrong. Now as we see, it has given all the details like the session id, target is class, the target type is binary, label encoded, original data size, missing values false, and all other features. Where where there is true, it means that it has performed that action. Now PC has already performed, so it has done it as false. Now these are the different parameters. Now we can do compare models. I am not executing it here right now, as it will give me, it will take a very huge amount of time. It will take around 15 to 20 minutes to compare all the models, as this is a very large data set and this command can be found from here. Best is equals to compare models. What this will do, this will give me a list of models along with the scores, and I can choose it from there which models gives the best. From this I got the model RF as my RF as my model. So I am taking here is I am creating the model RF for this problem. Now as we see, we can go to the create model part in this Pycaret website, and we'll be seeing different types of ID. Different model names have different ID. As we have chosen the random forest, it has RF as its ID. If we'll be choosing decision tree classifier, it will be written as DT. Now what I'll do, I'll create the random forest model. I have already run this because this will take around 10 to 12 minutes to get run. So in order to save time for you, I have already run this. You just have to simply type this command and it will create the model for you. Now as we see, it is provided with 10 folds, which means that it has run 10 times over different data in our test data, and it has given us the mean and standard deviation. Our mean score is 99.5 and has a kappa score is 85.5. As we see, we have a very good kappa score, which is often seen in an imbalanced data set. In an imbalanced data set, we often see the kappa score instead of seeing the accuracy, because it tells us best how the model is performed. Now, after selecting the RF model, we can see what all parameters have been selected. As we see, it is given random forest classifier, bootstrap true, alpha value 0, class weight none, criterion Guinea, and different other model. But we see that we can also hyper tune this model. How we can do this? We'll go to this part again. We'll see model training and we'll see tune model. This is the tune model, and it will give us how we can tune our model. It will tell us the tutorial that how we can tune our models with the help of different methods. You can see first we have selected the data. When we have created model, then we can tune the model in order to get the highest accuracy. Now it shows me that tune hyperparameters with increased n iterator. We can select our iterators, we can select the optimization curve. This happens if our employer wants us to specifically create a model based on a certain optimizer. For example, let's see if our employer has said that you have to create a model based on AUC optimizer. Though you can just optimize it based on EOC. The model which will be having the largest AUC score, highest AUC score, will be the first in your priority. Now moving on, we can hyper tune. I'm not tuning it here again, as it will take time. You can just simply do this or follow this command and tune it. It will take around 10 to 12 minutes again to tune this model, as it's a very large data set. In order to reduce the time, you can either cut short your data set into pieces for checking out how the model works, or you can wait for 10 to 12 minutes to get the model tuned. Now we have completely fitted our model. It's time to predict our data set. This is the I used the predict model. I passed out my model name and I gave the data X test, the data which I use. Now I am printing out the different results. As you can see, it has given me the different results. These are the data numbers. It has randomly selected a data, as it has 85,443 rows, which is the 30% of the total data, which is the test data I selected. Now this, as you can see, this is the label. This is the new column which has been added, which shows me if one, that means it is an outlier, and it's 0, then it means it is not an outlier. One, basically in this data set, 1 means that yes, this is a fraud transaction, and 0 means it is not a fraud transaction. And besides this, it is a score means 1 means it is accurately correctly predicted it, and compared, after comparing it with the test data, it has showed me that the score, yes, the score is right and the model is correctly predicted the output. So this was a short tutorial on how you can create the model, any model with the help of Pycaret library. Not this anomaly detection, you can create any model like it has classification, regression, clustering, anomaly detection. You can also create NLP models, association rule mining. There are different numbers of techniques, processing, split and split, data preparation. You can do all the different pre-processing techniques like missing values, changing data type, one hot encoding, ordinal encoding, cardinal encoding, and many other. The fixed imbalance data set, feature engineering, There are numerous amounts of activities which you can do with the help of Pycaret library and without typing many much of a code. Pycaret library is widely used by many different data scientists and other people in order to ease their work, and this can be very helpful. So this was a little tutorial on how you can create your models using the Pycaret library and also using the primitive machine learning techniques. You can visit this website, you can visit their website, have a look at it, and you can study these different models and implement it on your own with different data sets or in the same example. This data set will be provided to you, and this particular notebook will be also provided to you, so that you can have reference and build your own project. Thank you.